unit conversion and the train track method. But before we move on, there's 2 hints about this unit. Number 1, make sure it's the same units when solving. Okay, and number 2, units will act like a variable, aka x. So what I mean by number 2 is, you know how you do x times x, that equals x squared? If you do meter times meter, that will become meter squared. And if you do x4 divided by x to the second, that becomes x to the second. And if you do meters or centimeters to the 4th divided by centimeters to the second, that will also become centimeters to the second. So this, your unit will behave like a variable. So that's just a heads up. Here, all we're telling you is that we know that $1 equals 1,000 penny, but it can be written in 2 different fraction. The reason why it can be written with the dollar on top and pennies on bottom, and pennies on top and dollars on bottom, is because it depends on what we're starting unit, and then the desired unit at the end. Just depends, because we want the undesired units to be at the bottom so it cancels out with the top, and it leaves the desired unit on the top. And you will see what I mean by that. And we're going to use the train track method for this. So question number 1, it says a person average daily intake of glucose is 0.0833 pounds. What is the mass in milligrams? And then the units here given is 1 pound is equal to 483.6 grams. And another units we need to know is grams to milligrams. We know that there's going to be 1,000 milligrams for 1 gram, okay? And this is the unit, this is the SI units prefix you should know, okay? Okay, so knowing that, we can solve. Another thing, sig fig matters here, okay? So, heads up, when you do unit conversion, the numbers used for the unit conversion, those sig fig doesn't matter. The only sig fig matter is the sig fig that's given in the question. So here we have 3 sig fig. That means our answer should have 3 sig fig. Now let's go with the problem. So we're going to do the train track method. Okay, the reason why it's a train track method is because these division line looks like a train track. So first step is plan a strategy. We know we need to go from pounds, and we know we have to go to milligrams. But we're not given the direct unit conversion from milligrams to pounds. We're given grams. So that means our gram is our middleman. So basically, we're going to go to pounds to grams and then grams to milligrams, okay? So here we have 0.0833 pound. And then the question, we're given that 1 pound is equal to 453.6 grams. So since we want grams as our desired unit in the middle, I want to times it, make it this division line. I want my pounds on the bottom and our grams on the top, so that the pounds cancel out and leaves us with grams. If I do that, it leaves me with 37.78488 grams. And we want to convert this into milligrams. And we know that in 1 gram, there's 1,000 milligrams, right? So we want to put the grams at the bottom and 1,000 milligrams on the top because this is a desired unit and gram is the undesired at the moment. So if we times it out, we get 37784.88 milligrams. But since it's 3 sig fig, we're going to go 1, 2, 3, cut it off. And our answer will be 37,800 milligrams. Or we can make this look a little bit more prettier and put it in exponent. So we go 1, 2, 3, 4. So it moves 4 times. So our answer will be 3.78 times it by 10 to the 4th milligrams. And that's how you'll do that question. Now moving on to this question. This question is dealing with the second hint that I gave you guys in the beginning of this video about how you make sure you consider your unit as a variable like an x. So here there's no units given to us, but you should know that in 1 liter basically equals to 10 to the 3rd centimeters cubed. Okay, and then here we have a cube meters. So centimeters cube. Okay, the thing here. We know that 100 centimeters equals meters. But this is just with 1 exponent. We need 3. So what we're going to do is just cube all of this. So it's going to be 10 to the 3rd centimeter to the 3rd equal meters to the 3rd. And we can use it. So we have all the units that we need to solve this. So basically we're going to go to liters, to centimeters cube, to meters cube. Okay, so we are given that is 5.2 liters. And remember, sig fig should be 2 sig fig in our answer because in the problem we have 2 sig fig. So train track, we want to cancel out the liter, so 1 liter goes on the bottom, 10 to the 3rd centimeters cube goes on the top, cancel out. That will equal to 5,200 centimeters cube. Now, using this information that we got, we can cancel out the centimeters cube to get meters cube by doing this. So 100 to the 3rd centimeters cube equals 1 meters cube. Right? So the centimeters cube cancel out and we just divide it by 100 cube, leaving us with 0.0052 meters cube. And we like to have it in exponent form, so it goes 1, 2, 3 to the right. That means 5.2 times 10 to the negative 3rd meters cube. And that will be our final answer. There is more practice here. This practice is not using units, it's just trying to get you visualize the train track a little bit. So it's an international group of zookeepers with successful breeding program made a following animal exchange last year. Using the same bartering system, how many oryxes can a zoo obtain in exchange for 15 flamingo? So these are your answer choices. So could it be A, B, C, D, or E? So we have 15 flamingos and we're getting oryxes. I hope I'm pronouncing that right. So we're going to put 15 flamingo. Oh, that one goes here. Okay. Now, we're going to look here. Look for the unit with flamingo. It's right here. But unfortunately, it doesn't give me oryxes right away. It gives me anteaters. So we get 15 flamingo times by. So since this is our unit, we're gonna have 2 flamingos at the bottom. I'm gonna write it all out with 1 antlers at the top. Next step, since we don't antler is not our desired product, so right, because the flamingo cancel out, leaving us with antlers. So let's look at any other unit with antlers. This one has antlers in it, but it's camel, not oryxes. So that means you probably have to do another conversion. So we're just gonna, let's time this out. Actually, no, let's just continue making the train track. So I'm gonna put 6 anteaters here with 1 camel. The anteaters cancel out, but we have camel, not oryxes. So let's look at the chart again. And we know that 1 camel equals 3 lemurs. Oh my goodness, I think we're gonna go all over this thing. Okay, so if I solve this, I'm gonna put the camel on the bottom. So 1 camel right here with 3 lemurs. Cancel the camels out. Oops. But we have lemurs, not oryxes. So I don't have space. So let me put it down right here. So let's look at lemurs. Let's see which one has lemurs. Right here. There's going to be, since we want to cancel lemurs, we're going to put lemurs on the bottom. So it'll be 5 lemurs for 1 rhino. Yet again, not oryxes. Next step. Let's find rhino here. So we find 2 things that can convert rhino to 1 rhino for monkey or 1 rhino for 4 oryxes. And since we want oryxes, instead of going to monkeys, let's go to this one. Just make our life easier. So I'm going to put 1 rhino on the bottom with 4 oryxes on the top. And if we cancel that out, our final unit is oryxes. Now, I'm just gonna put the numbers on top that are on top and numbers on the bottom So basically it's gonna be 15 times 1 times 1 times 3 times 1 times 4 divided by 2 times 6 times 1 times 5 times 1. So if I do that, the top will get 180 and the bottom I get 60. And if I do 180 divided by 60, that will leave me with 3 oryxes. Oops, I can't spell. Okay, so that is how you get the answer C. Okay, moving on to more practice. So we're doing more conversion here. Okay. So we want it to be miles per hour to meters per second. That is a lot. So units I'm going to give you is there's 50 to 80 feet in 1 mile. There's 12 inches in feet in 1 feet. And then there's 2.54 centimeters in 1 meters. And the rest, and then there's 60 minutes in 1 hour. And 60 seconds in 1 minute. So, using that, I'm going to solve this. So, I have 29.00. So, that means this is 4 sig fig. Our final answer should have 4 sig fig. So, that mile per hour. This is how you write it. So first thing I'm going to do is I'm going to try converting miles to meters. So I'm going to put meters on the bottom here. The first thing here I know is that there's 50 to 80 feet in 1 mile. Cancels out. And I'm going to times it by feet. So I can cancel out the feet to 12 inch for 1 feet. That cancel out, leaving us with 1 inch. And although I know that in 1 inch there's 2.54 centimeters. That means 1 inch is going to go on the bottom, so I can cancel out the inches, leaving us with 2.54 centimeters. And using our SI units, I know that there's going to be 100 centimeters in 1 meter, right? So going back to this, I know there's going to be 100 centimeters in 1 meter. And that cancels out. And I know that I did everything right here because my meters is on the top, and so is how my answer should be. Okay. Next step is doing the hours. So I'm going to use orange. So HR. So do you see how the hour is on the bottom right here? So to cancel out the hour, I'm going to put the hour, whatever unit conversion comes first, hour on top. And the first unit conversion is 60 minutes to an hour. So I know 1 hour equals 60 minutes. So that hour cancels out right there. And I need to convert that minute to seconds. So I know that in 1 minute, there's 16 seconds. So I'm going to write it like this. And that's minutes. Cancel out, leaving with seconds at the bottom. And I know I did that right because my seconds is at the bottom, and so is how my answer should be. So if I multiply everything out, basically it will be 29.00 times it by 5280 times it by 12 times it by 2.54, and those are all 1, so I'm not going to write those. Divided by 100 times 60 times 60. So if I do that, I will get 12.96416. And this is the answer has 4 sig fig. I'm gonna get 4 sig fig. 1, 2, 3, 4. Cut it off right here. I round down, so my final answer will be 12.96 meters per second. And that will be your final answer. Okay. this is our final practice question for this section. Okay, it says you're in Paris and you want to buy some peaches for lunch. The sign on the fruit stand indicates that 15 peaches are 11.5 francs per kilogram. So let's write that down. 11.5 francs equal to 1 kilogram of peaches. Given that there are approximately 5 francs to a dollar, so 5 francs to $1, $1. $1. What pound? Calculate what a pound of peaches would cost in dollar. So basically, we need to go to 1 pound to dollar. So the only thing that's weight units is pound and kilogram. So we need to convert so that we get pounds to kilogram. This is not well known, but units I'll give you is that 1 pound is equal to 453.59 grams. And remember, using our SI unit, we know that since this is kilogram, this is gram, we know there's 1,000 grams in 1 kilogram. Okay, now knowing that, let's solve this. So 1 pound of peaches is times by 1 pound here is equal to 453.59 grams, times it by 1,000 grams, because it cancels out, right? Equals 1 kilogram. Okay, now we can use this kilogram, all the conversion information given in the problems now. We know that 1 kilogram of peaches equals 11.5 francs. So we put 1 kilogram equal 11.5 francs. So the kilogram cancel. And we know there's 5 francs for $1. So it's going to be 5 francs equal $1. And I know I did my units conversion right because I am left with dollars on the top. So if I solve everything out, I'll get my answer as 1.04327. And since we are calculating a pound is just 1. Our significant figure is 1. So just round it to here, cut it off. So that means 1 pound of peaches is equal to $1. Sorry, my dollar sign just didn't work. And that's how you solve it.